This is MATHguide.com, and my name is Mark Karanimos. Today we're going to take a look at how to solve equations, and specifically we're going to look at two-step equations. Let me throw one down, and we'll take a look and see what exactly we're talking about. So here's one equation I'd like to look at. So negative 3x minus 5 equals 7. Alright, well, first of all, why is this a two-step equation? Well, there is some value in front of our variable, and then there's some other value over here. And we're basically have two different numbers that are very near our variable that we're trying to get cancel, undo, however you want to think, but we're going to try to get this x alone. Alright, so the way we're supposed to think in order to solve this problem is to think in terms of inverse operations. So you'll notice that we're subtracting 5 from the left side of the equation. And so I'm going to do the opposite. I'm going to add 5. So I'm going to add 5 to both sides. As a matter of fact, I think I'm going to do that in black. So let's add 5 here. And let's add 5 over here. Alright, now the reason why we're adding 5 is because it's an inverse operation. It is the opposite of subtracting 5. And then nice things happen when you combine a number or an operation and its inverse operation in this case. So you have negative 5 plus 5, they cancel, so to speak, and 7 plus 5 equals 12. Again, I'm trying to be very neat, and I'm just bringing down this equation straight down. You'll notice this equal sign. It's coming down straight down. I'm trying to stay very organized and neat. Alright, so let's see. I'm multiplying the variable by negative 3. So what's the opposite? Well, the opposite is to divide both sides, or to divide by negative 3. And whatever you do to one side of your equation, you do the same exact thing to the opposite side. It maintains balance with your equation, and that's the point of doing it. So you'll notice that multiplying by negative 3, dividing by negative 3, those two values are going to cancel. That's where we use the word cancel in algebra so much. And again, I'm bringing down that equal sign straight down. Okay, I'm going to exemplify that again with the arrow. And then on the right side, we have 12 divided by negative 3, which is negative 4. And there's our solution. Now, we're not really sure if this is the correct solution. Well, at least not until we check the problem. So what we're going to do is we're going to go back to our original problem. It was negative 3 times x minus 5 equals 7. Okay. So in order for us to see if this is really indeed the right solution, we're going to take our solution 4 and we're going to place it inside for x. And that's why I left out the letter. I actually want to put that value in. So I'm going to put the value negative 4 and I'm putting that value in for x. And then what you do is you do the order of operations, and you actually see, will the left side be equal to 7? Well, let's see. So negative 3 times negative 4 is positive 12. And we still have to subtract 5. And 12 minus 5 is 7. And since we could see that both sides of our equal sign reflect the same value, this is indeed true. So we know that our answer, which we had over here, which was negative 4, we know that answer has to be the right answer. So we know that that's our way of checking, and it is then definitely the correct answer. Alright, so sometimes you can't tell whether or not you understand this until you see a few problems, and I always like to make the second one different than the first, because rarely are two equations do they look alike, and therefore are they solved alike. So let's throw in a different letter. They don't always have to be x's. They don't always have to be y's. So let's try the letter p equals 3. So we have 8 minus half p equals 3. So our letter that we're trying to solve for, called our variable, is p. we're going to try to solve for that. All right, well, in order to solve for it, we're going to do inverse operations. And you'll notice that I don't try to get rid of the coefficient or the number in front of x first. No, I never target this value first. I always target the value that's furthest away from my letter, but that's on the same side of the equation. I always try to pick that guy off first. So how do I get rid of a positive 8? Because right now it is a positive 8. So to get rid of a positive 8, I'm going to subtract 8 from both sides. Whatever you do to one side, you do to the other. Now I know this is the right thing to do because look what happens. I have an 8 and I'm subtracting 8. And when you get two values to cancel, you know you're doing them. You're doing the right step. You know you're doing the right inverse operation. So now I'm going to bring down this half p. And then over here, let's see, I got 3 minus 8, and that's going to be negative 5. All right. Now, you'll notice that also, I'm trying to really make sure that people see the fact that I'm bringing down the equal sign, just bringing it straight down. All right, how do we get rid of that negative half? There's a few ways to do it, and the way I like to do it is, well, if I'm multiplying, right, I'm multiplying p times this negative half, what I am going to do is I'm going to take this negative half and I'm going to multiply it by its inverse. It's multiplicative inverse. In other words, it's reciprocal. So let's see, the reciprocal of this is 2 over 1 with a negative. So in other words, if you take the reciprocal of 1/2, you get 2 over 1, negative 2 over 1. And I'm going to multiply both sides by that value, negative 2 over 1. You're thinking, well, what does this accomplish? Well, you'll see that when we multiply these two things together, let's see, a negative times a negative, that's a positive. And when you multiply fractions, you multiply numerator times numerator, denominator times denominator. So you're going to get 2 over 2p. And here right now that's negative 5, which is negative 5 over 1. And again, you multiply straight across with fractions, numerator times numerator, denominator times denominator. So you're going to get positive 10. Alright, so let's just clean up the left side. 2 divided by 2 is 1, or just 1p. And 10 over 1 is 10. Okay, again, what we're going to do is we're going to check to see, is this really the right value? So we go back to the original problem. And I'm rewriting it. I'm just not putting in the letter. I'm not putting in the letter P. Instead, I'm going to replace it with what we think is the right answer. We're going to replace that with 10, and we're actually going to do some calculations and see, is that going to turn out to be the right answer? All right, well, order of operations says we multiply first. So let's see, half of 10 is 5. And 8 minus 5 is 3. And since both sides are the same, it checks out. It checks out that those two values are the same. It means that this value 10 that we arrived at when we solved the problem is indeed the correct solution. If we would have gotten two different values, it would have been something like untrue, like 5 equals 10 or 18 equals negative 7, something that didn't make any sense. You would have known that we had the wrong solution. We would have to go back and see what we did wrong. But in this case, we're great. So we got the two answers. That's how two-step equations work. All right, so make sure you go back to MATHguide.com. You look at all the interactive quizzes, other lessons, and activities. Take care.